Hello and welcome everybody to Udacity Robotics Q&A. I'm Mike Salem and I'm here with CEO and co-founder of Kiwi, Felipe Chávez. Felipe, how are you?
Very good. Thank you very much for inviting me. I'm pretty excited to be here today.
Great. We're glad to have you in studio today. Thank you very much for stopping by.
Okay,
I was wondering if you could tell me a little bit about Kiwi Robotics and exactly what you guys are working on.
Okay, so with Kiwi we are building robots for food delivery. So basically our goal is to build out the first robot urban infrastructure that allows us to deliver with robots. Yeah.
Cool. So where are you using these robots? Where are you deploying your robots right now?
So we think that in order to deploy faster and iterate our product better, we need the perfect spot to do it is college campuses. So that's why we started at UC Berkeley, and right now, like next semester, we're going to start in a second campus. Yeah.
Okay, great. So what it sounds like is you have a mobile robot base.
Yes.
That you take and you kind of deploy around campus and then it drops off food for hungry college students.
Yes, one of the things that we realized is that actually delivery is very expensive. Yeah. So when you try to order a burrito, a $9 burrito, you end paying $5 for the delivery fee, $3 for the service fee, and also you have to tip. So I'm very involved with the student community, and like we students are broke, so we don't have like enough money to pay luxury. So we basically started to rethink how delivery works, and we started to see that it's not truly optimized, because like, for example, if you order from an on-demand app, it's just one person going to a restaurant and then go to the customer house. But with robots, we can actually start to group robots and optimize a lot of things, so that's really fun.
So with your robots, can you actually do custom orders? So can you go to multiple restaurants, do multiple orders from smaller, let's say mom and pop type of shops?
So one of the things that we have learned is that in order to deploy robots to real life, we still need humans. So for example, in UC Berkeley, we still have people in the restaurant zone that is in charge of, for example, if we don't have a partnership with the restaurant, or the restaurant doesn't have our app to receive our orders, we just have a person that is going into the restaurant, buys the food, picks the food up, and the robot is in front of the restaurant waiting for the order. Right, so we still need humans to empower this infrastructure. Yeah.
Cool. So can you tell me a little bit about the size of your robot and maybe some of the sensors that you have on board?
Yes. So we started like our first approach was to basically build the network software so we can actually control the robots, right? Mm-hmm. So to do that, we started with a basic parts. So we used an Arduino, a Raspberry Pi, an IMU, and also one of the things that we have suffered a lot, but we already solved, is internet connection. So we have to ensure that we have very good LTE at any time. So that's why our robots use on a smartphone. Yes. So that's the other computer that we have in the robot. In the first version, we use like laser sensors and also ultrasonic sensors. Mm-hmm. But as soon as we started to work more with computer vision, we started to try to replace those sensors with cameras.
That's really interesting, because a lot of people seem to be going the other way, right? They either start off with like, I need a LiDAR and I need 15 or 20 ultrasonic sensors because I'm worried about running into things. You've taken more of a computer vision approach and kind of really cut back on the amount of sensors you need and trying to run pretty much everything right off of your camera. Yes,
I think that in order to solve automation or self-driving, you need to solve vision. You can't do a self-driving robot or a self-driving car without solve vision. So that's fundamental, and that's why we are investing so heavily in that. And basically what we are trying to do is to, for example, our main problem is to ensure that the robot is inside the sidewalk, yes? Mm-hmm. And it's actually pretty challenging. Like for me, in my perspective, it's easier to ensure that the robot is in the that the car is in the road between the lines.
Sure.
But with a robot in our sidewalk, like every sidewalk is different. We don't have the lines to make the line detection. So we have, for example, we are using lateral cameras to recognize buildings, to recognize trees, to try to identify the curves. So all those things, like we are using a camera as a sensor. And we are using like the same approach of sensor fusion, but just with cameras and GPS. Yeah.
Interesting. So how many cameras do you actually have on board of your robot?
Yeah, 6 cameras.
6 cameras?
Yes.
And you're able to kind of pull all of that information together to make a decision? Is that how that typically works?
Yes. So right now, what is interesting is that not any sensor is totally reliable. Yes, not even GPS. Well, there are some GPS sensors that are super reliable, but are really expensive, yes, and when you are actually building not robots for research but also robots for delivering, you need to make sure that the robot is going to pay by itself in the future. So that's why we are using these approaches. Yeah.
So how big are your robots approximately?
So the new model is 25 centimeters. Well, we have the chassis that it's 12 centimeters.
Okay.
I think that you need to measure in inches. Maybe
well, centimeters is okay, right? So that's roughly about half a foot?
Yeah,
so about 6 inches high, roughly? A little bit less than that for everybody out there. But
yeah, exactly. One of the things that we identified is that our first version was a little bit bigger, yes, but we are working in sidewalks. So sidewalks are like a really sacred thing for people. So that's why our robots, we are trying to build robots that are not going to bother people. That's why it's size, like having a small size matters, and we have to optimize everything inside the robot to have enough space to transport 2 meals. So our robots, the payload capacity, it's 5 pounds, and we can actually we want to just transport 2 meals. Yeah.
Okay, so it's meant for a 2-person delivery, which is typically a good size. Usually it's you and a friend, maybe it's 2 separate people, 2 different locations, so it's a little bit more of an optimization and logistics problem, but it's still meant for really kind of light, easy travel.
Yeah, exactly. Actually, our weak point is pizza. Yeah, we can transport pizza, but we think that according to our the orders that we have received, and we can cover with our current model 95% of the orders. So yeah, it's good.
Sure, and there's already pizza delivery robots out there.
Exactly.
Domino's has their pizza delivery robot, right?
Yeah.
But what they don't have is a mom and pop restaurant delivery robot, right? So you have a leg up on Domino's already.
Yeah, but the thing about when the first and I think that this could be interesting. So my background is in delivery space. So I have been working in the delivery space the last 4 years. Of course, I have been an enthusiast in robotics and also in AI for several years, but I always thought that will be super difficult. Like, do you need like millions of dollars, and that you need scientific, do you need scientists, like a lot of things. So the first approach was, well, there are companies like Domino's that they're building their own robots. Maybe it could be a good idea to buy those robots, yes, or to try to rent them.
Sure.
And the thing that we actually encountered is that there are a lot of robotic companies that are making research, yes. So they're building just one robot at a time and making sure that it's 100% autonomous and using expensive Velodyne and LiDAR sensors and things like that. So that's why we decided to build our own robots. And until now, we have delivered, since our launch 10 weeks ago, we have delivered 2,000 orders with our robots. The last week of classes, we delivered 500 orders, and we were the company in the world that made more deliveries on demand. Yeah, with robots.
Wow, that's fantastic. Yeah. Congratulations.
Thank you very much. Yeah.
So I know you mentioned a little earlier that your background is in more of delivery.
Yes.
So it sounds like, I believe your background is related more to business side of things,
yes,
and not so much the technical side of things.
Yes.
What are some of the struggles that you've kind of encountered when you were starting your company that you felt like you had to overcome not being from the technical background?
There is a good thing that I want to tell, and is that most people, when you are hiring, try to overestimate experience. So when people are hiring, are trying to look like what you have done, what is your experience, what is your background. But for example, right now in my team, I have bring some people that are new in the area, that maybe don't have some experience as me. And what I have encountered is that when you have someone that doesn't have too many, doesn't have too much experience, they don't know what is impossible. Yes. So when people don't know what is impossible, they can actually achieve very interesting things. So I remember that the first time I asked someone with like a lot of with very strong background about using neural networks or computer vision to object detection, he told me that I was crazy and that that will take like a couple of years. But we did it in a couple of months. So that are the kind of things that when you don't have experience, maybe that could be a good thing. And this space is totally new. Like we are totally new in this space. So yeah.
So what you're doing is you're really kind of curbing your expectations. Instead of kind of lowering your expectations immediately because you feel like, well, I have enough technical background in that area that I know this is going to be a complicated or a hard problem. Because you don't have any of that background, you necessarily say, I just want to go and do this. You try it and you see how long it actually is going to take. And you think that's more beneficial for you and your company in the way that it's operated so far.
I think that, for example, like I'm not an engineer, but it's really important that you actually understand the fundamentals. So I remember that when I was in college, I thought that algebra, linear algebra, and calculus. I'm not going to use that at any time in my lifetime. But actually, I'm now using it. Yes, because now to understand the fundamentals of machine learning, I remember that we had a problem with a PWM thing with the sensor that we were.
PWM is pulse width modulation, correct?
Yes, okay. Exactly. That we had a problem with the Arduino, so I actually had to recover my small knowledge in integral calculus. So those kind of things actually, like if you actually just know the fundamentals, it's okay. But if you are going to start a robotic company and you are not, you don't have technical background, you must be like, it's very good to, it's mandatory that you actually learn a little bit, like you know how it works. Yeah.
I think that's great advice.
Yeah.
How important do you feel it is to find and build, and how difficult was it to actually build a technical team to kind of help you execute?
Well, like right now we are 14 people in the team.
Wow, it's a big team.
Yeah, and 12 of them are engineers. So just the designer and me are the ones that are not engineers. And I think that the very good thing that I'm using right now to hire people is I try to first have a conversation as friends, and if I start to have the feeling, like before the technical part, before if it's very good at the technical part, I try to hire people that I will not have any problem if that person is my boss. Yes, so that actually have worked very good with me, like hiring people, and it's the number one technique that I use in order to know to know how I'm going to build my team. Yeah.
Sure. So having a culture fit is such an important piece of your team because you feel like you're a very tight-knit team.
Yes, I think that this is a very complex problem. Yes, we are tackling a very complex problem. So there, for example, last week was very bad. Like we have a team that is working in image recognition. So they are managing a lot of libraries, OpenCV, a lot of things, and we didn't have any results. So there are very stressful situations. So if you actually build a team that you feel comfortable working with them, and that's the most important thing. So I think that we are going to solve and to tackle all the obstacles that we are going to face. It's because we have a culture, and that's super important.
I think it's a great attitude. I actually used to work for some folks that one of the things they'd mentioned to me is they said you always hire people smarter than you, because if you hire people that are smarter than you, you know they'll be able to accomplish everything that you can do and more.
Yeah.
So it's a great attitude and a great philosophy to have. Yeah. So I noticed you said that you have 14 people on your team.
Yes.
And there's only 2 people on your team who are non-technical, and
yes.
It's you and another designer.
Yeah.
How instrumental do you feel your designer is to your team and how everything has been built so far?
So I think that design is pretty important when you are building robots. So there is the Baxter. Yeah, that robot. I remember that I read I read about them, and it totally changes when you put a face into the robot. Yeah,
sure.
So because the robot has a face, so they solve a lot of problems just putting a face. So for example, our robot, because we are interacting with people, it totally changed everything when we put a face and into the robot. So right now we are trying to build a robot that looks more like a pet, yes, so that people actually can protect it, can take care of it, that can actually forgive an error or a thing like that, than building a super high-tech, actually we're building a super high-tech robot, but we prefer to build robots that seems very more like a pet. So design, it's really important. It's
because it's mainly human perception, right?
Yeah,
so
sure.
if a human perceives a robot in a certain way, they tend to behave around it in a certain way.
Yes.
So if a robot looks very high-tech and complicated, they might be a little bit more standoffish and more like, I don't want to be around that thing. But if it looks more like a pet, you feel like, oh, I can interact and I can engage and I can walk and I don't really have to worry about what this thing's going to do.
Exactly. Yeah.
So there's some interesting other aspects to your design as well, and one of them is your speed of your robot.
Yes.
So how fast does your robot typically go?
So right now we can go up to 6 miles per hour, but that's not. I think that's not a very good speed in sidewalks, because right now we try, the average is 3 miles per hour.
Sure.
So we try to do it lower than the human speed, like the human walking speed, just for safety reasons.
Mm-hmm.
Yes.
So that makes people feel comfortable around the robot too.
Yeah, exactly, yes.
So let's shift a little bit, talk a little bit more about your CEO duties,
Okay.
and kind of talk about what's your day-to-day, what are the types of things that you typically focus on as a CEO?
So, maybe this is not too much involved with robotics, but my main, the main thing is to actually, there's a good man management skill or technique that I use, is that, for example, when you are tackling robotic and engineer problems, it's always a version of that problem that you can solve in 3 or 4 days, right? So right now we are trying, and that's why we ended up working with the sensor fusion thing. It's because, for example, if I tell my engineer team, like, hey, build an autonomous robot in the sidewalk that doesn't need any human interaction, they're going to tell me like that's very challenging, like we are going to need a lot of time. But if you just tell them like, hey, I just need a robot that goes from one corner to another corner straight, it doesn't matter if it has collision avoidance, that small problem, or just recognize the traffic lights. So it's very important. One of the jobs of the CEO is, first of all, make sure that everyone is aligned in what we need to solve. So our first priority for the next semester, the next stage, is make 1,000 orders per day. That's the challenge, and we want to do it in a 2 miles radius coverage area. So that's going to be actually the first robot infrastructure in the history. So if you have that part, like people actually start to build not computer vision for the sake of computer vision of AI, but most like thinking how we can achieve like the 1,000 orders, maybe, because we still need, like, our robots are not totally autonomous. We still need a person that is making surveillance, that is helping the robot to make the crossing the streets. So yeah, so that's one important thing.
So it sounds like you're doing a lot of strategic planning. So you're actually giving your team a set of small-term goals, small, short burst goals,
Yeah.
with a long-term horizon as to what you want to achieve.
Yes.
So by saying basically, I want you to take the robot and go from one corner of the street, of the sidewalk, to the next corner of the sidewalk.
Yeah.
That's all I care about. Let's do that. Then you at least have a base and you have a benchmark and you have a baseline to do things with. And then from there you could say, okay, now that we've done that, now we want to make sure it doesn't run into any people, right?
Yeah.
And then you slowly build on it. So you're giving this order to the rest of your team, but you're giving it to them in doses that they can handle, so they don't have to worry about all of the other things that could go wrong, whereas you have the opportunity and the ability now to sit back and think about those while still allowing them to focus on the task at hand to help them progress and move forward.
Exactly. Yeah. So it's better, like this space is talking about computer vision and like deep learning and also some sensors. It's so new and you have a lot of things to discover that it's easier. And I actually advise to tackle small problems. Don't try to tackle like self-driving, totally self-driving. Try to recognize what small problems you can solve. Yeah.
Great. So talking about a little bit about kind of when you started out with your company, you had your vision, obviously you wanted to do something in the delivery space, you had some background there,
Yeah.
and you had an idea and you knew robots would work out really well. Talk to me a little bit about your process of how you went about putting things together to kind of go and present and talk to companies to try to achieve funding.
Yes, so the first thing is to like when we started in Berkeley, we started with robots, and the first, the most important thing is to actually have people that want to use your service. Yes, so we actually had a lot of demand, but we were just bootstrapping. We didn't have any funding, so like we didn't have enough money to pay like delivery and couriers to actually make the the deliveries. So we were in a situation. I remember that there was one week that like most of my job as CEO was actually making deliveries. Yes, and I started to think like how I can solve this. Of course, my solution was so extreme. So because I remember that the first time we were like that, we started with a side project. So there is this company called PlumGeek. I don't know, have you heard about it?
No, I have not.
So PlumGeek build educational robots. So and our first side project was to hack an educational robot. So that was a small book, and we basically installed an AI software in that book, and we basically made our first object like collision avoidance and things like that. But that was a side project. But what we identified with that side project is that this is achievable, that the technology is actually improving and a lot of things, and everything like the planets got aligned. So like the things with the robot that we hacked were actually going very well, and we had a lot of deliveries, and we didn't have enough time to make the deliveries, and also don't have any money to pay couriers and to train couriers and hire couriers. So we decided to make the first prototype, and we built it in 1 week and a half. So with that prototype, I remember that we made half of a delivery because we had some problems with the battery and the sensors. But then I thought that this is possible, and I fully committed. So I tell all my customers like, hey, I'm going to stop 1 month. Please wait me 1 month. I hired 3 new people like that are involved in robotics, and we built our first version. That was 10 weeks ago. Yeah.
What was your customer's reaction when you came to them? Obviously, you had a base already of people that were interested and were getting your service. You were giving them deliveries. I know you were making deliveries personally. Yeah. What was the reaction once you pulled back and told them, I'm going to take a month off, and I'm going to go work on something, and I'm going to come back and do this again? Yeah. Did you have any problems with your customer base when you did something like that?
I spoke with some customers, and they told me like they thought that I will close the company. Yeah, that was the first reaction. But then 1 week before we started again, I sent them an email with a picture of the robot, and the first reaction was that we received that day like 20. Just that in that night, we received like 25 internship requirements. So all the students, all our customers want to be interns in our company. So that was very great. Yeah, I felt very happy. Like people started to see, oh, now this makes sense. Yes.
So what I think is kind of interesting about your company, and I had a conversation around this earlier this week, is that robots aren't the focal point of your company. The focal point of your company is actually food delivery, right? Because building a robot is great, it's nice tech, like people like to play around with tech, but you're not really solving the problem, right? When you just build a robot is what I'm saying. So, but you've built a robot with the sole purpose in mind. How important do you think that is for other people to kind of follow in that model and that vision of, you know, the robot is the tool, it's not the end goal?
I think that it's last week an investor asked me like, you're a delivery company or you're a robot company? So it's like, I don't know, it's like asking Amazon like 20, 30, like in the 90s, like you're a book company or you're like an internet company. So I think that robots in delivery space and logistics space are going to be mandatory. So you have to work on that. And what we have found that we didn't found any solution available, a very good solution available. So we decided to build our robots, like with ourselves, the robots. Yes. So it's interesting because, for example, when I hired people, a lot of people have worked in robots, but just in the research part, like just for like we build it, but we didn't, I don't know, sell it or put like build 100. Right now we are in August. We're going to have 100 robots. So actually building robots more in a consumer scale, it's fun. and you have different approaches and different challenges. Yeah.
So can you elaborate a little bit on some of those challenges that you have once you start having robots at scale, some of the things that you kind of see coming up on your horizon?
Yeah, it's like the same when you are working with just one person. If you are working with just one person, it's totally different when you are working with dozens of people, right? It's the same with robots. So if you make a robot work, just one robot, it's okay, it's good. Now, it's a total different challenge. I remember that one of when we make the first goal of building one robot, the next challenge was to have 10 robots working at the same time, yes? And that was pretty hard, yeah. We already built one, but actually to have 10 signed and worked at the same time, it's really difficult. And in logistics are the same. So I think that what actually differentiates us is that we actually have proved that we can have several, like dozens of robots working at the same time, and by the next semester, hundreds of robots working at the same time. And it's a total different story, yeah.
So I know you have a couple of fail-safes too that you have to have when you're working with your robots. So there's certain situations where you have to be very careful because you are interacting with people and you're around people. So one of those is, I'm assuming, is around children, let's say. So what kind of methods do you have in place to kind of handle when your robot is around a child?
Right now we are trying to use computer vision to identify when we have a person that is really close to the robot, and also to identify the size of that person. So, but for example, we always have a human. We have an operational team in Colombia. We always have a human that is watching the robot remotely. Yeah. So every time that a kid starts to play with the robot, every time that we are passing through a very crowded sidewalk, the last 30 seconds, 1 minute of every delivery, we do it with a human to ensure that the delivery is successful. We do it with a human. So by now, we're using, in those extreme situations, humans to take control and make the right decision. Yes.
That's great, and I think that's a really important piece, that you have a human in the loop to kind of handle those complex situations. A lot of times you'll see people will just rely on their algorithms, and what ends up happening is there ends up being an error or something unpredictable has occurred, and it's caused all kinds of different problems. So you get some negative press over things like that, but having a human in the loop kind of alleviates a lot of those problems.
Yeah, and I think that just in the technical part to that, the challenge to do that is actually a network challenge. So I think that right now between 20 and 30% of all our code is related with network. So we need to ensure that we have latency below 150 milliseconds to take control of the robot at any time, that we can actually stream video in a very good quality with very low latency, and also that we actually don't spend too much money in data plans. So those kind of challenges are very interesting, but I'm very optimistic that the future is going to allow companies to build robots, and we will be able to connect to those robots very easily. Yeah.
Interesting, great. So I know you mentioned you have an operational team that's in Colombia.
Yes.
Is that originally where your company came from when you started this?
Yeah, I'm from Colombia.
Okay.
We started the company here in the US. Our headquarters are here, our customers are here, we build the robots here in the US, our investors are here. For example, half of the team is from Colombia, and the operational team is in Colombia. So, yeah.
Okay, great. And I don't know if you can speak on this too much, but how is the robotics scene in, let's say, South America? Is there anywhere in particular that you know of that there's a lot of robotic activity?
I'm very sad about that, but because we just read a review of all the startups that are working with robotics in Latin America, and until I know, we are the only startup that came from Latin America that are venture backed, that are working with robots. Yes, that have raised more than $100,000.
Wow.
So that means that there are not a lot of people working in robotics in Latin America. So one of the challenges that we want to do with Kiwi is to actually inspire people that you don't need a lot of resources, because the first thought that you have when you are building and creating robots is this is going to cost a lot of money, and this is something that it's magic. It's like black magic. You can't do it. So one of the things that we want to do, and we want to make sure, is that empower and inspire more people in other parts of the world to start working robotics. And also here in the U.S., I told you that the CEO, the Velodyne's CEO, said that there is a trend, there is maybe a hot market, but there are not too many companies and startups working with robotics yet. So we need more people working in this space. Yes.
So I want to kind of touch back a little bit on South America as well. What do you feel would be beneficial for some of the folks down there to try to get going? I know things, the socioeconomic situations down there are a little bit different than they are here in the United States. What type of things can they do to try to, either start their own companies and kind of try to get ventured back in South America, or to kind of, look for jobs? Should they pursue jobs elsewhere? What are some of your recommendations?
Of course, one of the recommendations is to take a course in Udacity. That will be a very good start. One of the things that we have done is that, because we have some people in Colombia, is to build a synthetic environment. So what that means is that right now we are building a 3D environment, yes, a little bit photorealistic, so that actually people can start to work with simulated sensors, simulated computer power, simulated robots, and train their software, their algorithms, their CNN, their neural networks, all the things. So I think that could be a good start to actually be able to test a lot of things, because one thing that we have encountered with our robots is that almost 20 or 30% of the data set that you gather with real robots are not in a very good condition, a wrong data set. So we are also very heavy in build an entire city with sidewalks and with humans and with cars that people will have access to train their own robots. Yeah.
That's fantastic. And are you planning on open sourcing this data set of this information, the sensor data?
Yes, we are still too early. Yes, we are also working with Udacity on that part, and we are going to have some announcements on that. But totally, my fundamental willing is to have more people working in robotics. That I will be super happy. That will be an achievement for me. Yeah.
Are you familiar? Do you know who Yogi Berra is?
Yes.
Have you ever heard this saying? It's one of my favorite sayings ever. In theory, practice and theory are the same. In practice, they're different.
Yeah.
Right? Yeah. So it's exactly what it is when you're dealing with hardware, right? You have all this noise, nothing ends up working correctly. So giving people the opportunity who might not be able to afford those sensors, like for instance, not everybody can afford Velodyne LiDAR, right? You're giving them the opportunity to at least see some sort of real data and from a real environment, and allowing them to play around with that actually is huge for lots of people and lots of folks all over the world. So I think you're doing some really cool and interesting work. So thank you for that.
Yeah. It's still too early, but we have very good progress on that. Yeah.
That's great. So shifting gears a little bit more back to your idea of some of the sensors that are on board. I know you had mentioned earlier that you have 6 cameras, you have an IMU, you have a GPS. How do you see, once you start scaling, like you said, for the 1,000 robots, there's going to be some logistical planning kind of in place for that. Yeah. So what do you see are some of the new and emerging fields in robotics that you think might help you kind of tackle those areas?
One of the things that I think that there are not enough companies working is manufacturing robots. Yes, when you build a robot, and it's because it's not sexy. Like like a lot of people see manufacture like something like I don't want to work on that, but it's actually pretty fun, and I think that it's very important. So if you build a robot, and if you want to build the robot that builds the robot, that's like an order of magnitude more complex.
Sure.
Yes. So I think that in order to have this new revolution of robots and machines, like improving the world, we will need more companies like working in manufacturing. That's a thing that I'm eager to have more companies working on that.
And that's something that most people don't realize, right? So you're a small shop. You start off, you make one robot. You're like, I got a prototype. This is great. Now I got an order for 5. Okay, well, I can make 5. And then you say, I got an order for 50. I can make 50, 100. 1,000? Well, now all of a sudden, right, you're hitting this cusp, this breaking point. Okay, 10,000? Okay, I definitely can't make 10,000 out of my garage, right? And I think this is one of the biggest problems that people are kind of facing right now. So I 100% agree with you.
Yes, and actually in our process of building our robots, we still need a lot of humans. Yes, like there are a lot of manual procedures that I'm pretty confident that there should be a way to build a robot to build a robot.
Yeah, so I agree.
And that's super exciting. Like if I have to start a company later, it will be in that field. I'm pretty excited about that.
Awesome. Yeah. So are you familiar at all with swarm robots and swarm theory?
No.
Okay, so the idea is basically that if you have these small entities, so for instance, birds is a good example. So where you have birds that are flying, they end up flocking together and they end up looking bigger than they are, actually to help, avoid being attacked by predators, right? Okay. So other examples are in ants. They use they emit a pheromone as they're going down the trail, right? So it's the idea of swarm theory. So with your robots, with your food delivery, have you thought about investigating this area at all for kind of swarms? Once you start realizing that you're going to be doing a lot of these robots at scale, you can use them for a catering situation, for instance, right? You could take 20 or 30 of these robots all delivering food to the same location in this big army of robots right to somebody's door. Is this something that sounds interesting to you, or something that you've given any thought to yet?
Yes, I don't think I haven't made that thought like in the business side, but in the fun side a lot. For example, right now, like a lot of customers ask. I remember this customer that asked me if she can rent the robot for their sister birthday, like little sister birthday party. So those kind of things, of course, like robots, that kind of things are going to happen. And there is an important thing that we are working on, and it's to actually communicate robots. Yes. So in order to achieve that kind of things, you need to have sign them and to find ways to communicate one robot to another. So for us in the logistic part is fundamental. Like we need to know where is the robot and if we have a robot close to another. So for example, we are using we have almost three GPS sensors in the robot, but we are also using Bluetooth in each robot to recognize. So, for example, I don't know, if we lost connection for any reason with one robot, we can recognize a robot that is closed just by another robot that is passing really close to that. Mm-hmm. So those kind of things, of course, we are too early in that part, are going to achieve, to help us to achieve that kind of solutions. Yeah.
Great. So let's go ahead and take some questions from our students and other people of the community.
That will be great, yeah.
So I'm hoping that people out there have some really good questions. Make sure you can post your questions on Questions for Kiwi in our Slack community or on our YouTube live comment section right now. So this first question is for Naeem Kabir. I know this is a technical class, but I'm interested in the reasoning behind Kiwi's choice of target market. Why choose college campuses specifically as a target for food delivery fleets of bots?
I think that students are awesome. If you're going to build a company, it's really important that you build it like that you really like your customers, yes, because you're going to solve their problems. And college campuses are, you have early adopters, and you have less variables to control. The people are super friendly. You can find talent. So right now, half of our team is from UC Berkeley. That it's our first campus. So it's our vision is to be in more campuses, and it's easier for us. So I totally advise that it's a very good market. So if you want to test a solution, or not even if it's robotics, it doesn't matter. But it's a very good market to start.
Perfect. Yeah. So the next question is from Pradheep Krishna.
Okay.
Hey, how do you make a low-cost robot? What approaches do you take to reduce the cost?
So I think that when you're working with robotics and with engineers, they're you feel very tempted to use expensive parts. Yes. So let's use the expensive stereo camera
sure.
for 3D mapping, let's use the most sophisticated GPS. Let's use the board that have the the more computer power. But we finally choose that. Like we are using our robots to use a Jetson TX2. That it's a very good.
It's a great
one.
board. Yeah.
Yeah, it's a great board. But I think that it's really important to try to be recursive. Yes. So I feel very grateful to don't have a lot of funds in the earlier before, because that pushed our team to be resourceful in using cameras to replace sensors. So actually it's a very good spot to don't have a lot of funds when you're building your robot, because you're going to try to do it with very low money, and then you can innovate a little bit. So yeah.
Great, thank you.
Yeah.
So the next question is from Igor. He wants to know if you're hiring.
Right now, we are always open to have new people in the team. So yeah, feel free to contact me if you're in the Slack group of
Slack
robotics,
community, sure.
Slack community. Feel free to contact me. Yeah.
Yeah. So if you're not in that community, make sure you sign up for that community so you can meet people like Felipe.
Yes.
So the next question here is from Leno Tavares Cabral.
Okay.
Excuse me. Sorry, Leno. If I want to make robotics, I need knowledge in passive and reactive circuits. So this might not be a question.
Yeah, like it depends on which robot do you want to build.
Sure.
Yes. So yeah, it depends on which robot.
Sure.
Yes, yeah.
Makes sense. So next one is from Nitish Prasan. Do robots need internet connection, or can they function without it? On which network does it rely to communicate with other devices?
Okay, so that's a very good question. So a lot of the computer vision, it's safer to do it on site. So right now, for example, with the computer vision, and if you are using just one part of the computer vision, that is, for example, machine learning and neural networks, the first step is to make sure that it works. Yes, but then you actually can optimize the neural network a lot, so that the size is lower and also it's lighter to put it in a computer. We have made some tests that we run some machine learning process in just a Raspberry Pi. That could be like a small computer, like a shared computer power. We have also tested with cloud computer processing. That is not like you have it's maybe a little bit more riskier, but it's something that we have to stream. We have to make sure. That's why I said before that you need to one part of the robotics is to make sure that you have a strong network software. So yes, so you can do it, and we are using T-Mobile, but it depends on when you're going to deploy your robots, because we have to test it with all the carriers. We test it with all the devices, the hotspots. So it's a very interesting benchmark, and it depends a lot in when are you going to deploy your robots. So
sure.
Yeah.
Great answer. Thank you. So the next one is still from Nitish. I've heard that robots will replace about 1/3 of the actual human labor force in the future. Yeah. Do you think that's true? And will only programmers and robot maintenance resist to that trend?
I think that it's too early to talk about that, but I think it's true. Yes. So one of the things, for example, a lot of people ask me okay, you are replacing normal couriers with your robots, and my first answer is that students can't afford to have food delivered, to have a service, to have food delivered. So the first thing is that we are actually making sure that a lot of people can live with less money. So that's one part. And there are interesting experiments that a lot of people are doing in that part, because, for example, self-driving. The self-driving technology is going to replace, I think that 20% of the jobs are involved with driving a car.
Mm-hmm.
Yes. So that's something that is going to happen. It's unavoidable. So there are techniques like experiments like universal basic income that have showed that I think that could be very interesting. And I think one of my friends are working with human augmentation. So I think that there is a very powerful solution to actually connect robots and software and computers with human brains. So that could open new possibilities. But the most important thing is it's still too early to talk about that, but we can't stop the robot and the machine learning and all the computer vision revolution, because it's going to allow to have a good life, like it's going to have less poverty and a lot of things, yes.
Yeah. So next question is from Pradeep. He wants to know what kind of wheels you use in your delivery robot.
So in the first one, we basically hacked an RC car, the first version. So I basically, like, there is a big community of RC enthusiasts in the US. So I remember that I went to a race of just RC cars, sure. And I surveyed all the people, like which robot it's like according to our characteristics. Mm-hmm. And the decision that we made is that we used an Everest robot, but it's a normal RC car, and we hacked that robot. In the new version, we are testing with different chassis. One of the chassis that we are testing, it's called Nomad, and it's a 4WD that we can go to any direction and can turn in our own.
4WD meaning four-wheel drive?
Yeah, four-wheel drives. Yes, so there are a lot of solutions out there in terms of chassis, and yeah.
Cool, great, thanks. Next one is from Ricky. He wants to know what programming languages you use.
So in our, like, for example, in the old network part, we are using Java, yes, and we are also using C in our right now we are testing with some parts. So I'm not sure, like, if we are going to use a PFX Mini or if we are going to use a Pixhawk or what kind of connector we are going to use, and it depends also in the language that you are using, the programming language. For the image recognition part, we are using Python, mostly Python, and in the neural network part, we're using a framework that is called Keras,
mm-hmm.
And yeah, so
a lot of our deep learning students are familiar with Keras.
Yeah. So it depends, because it's a really complex problem, so you need a lot of languages. Yeah.
Great. So next question is from Alvaro. Does your robot track pedestrian position and velocity? I wonder if you can adjust the robot's velocity and trajectory based on this data to speed up the deliveries.
Yes, that's one of the challenges. The thing is that there are some blind spots. So I don't know. For example, we're in Telegraph, in one of the main street. You can actually speed up the robot, but there is someone that could be like going out from a restaurant, and it's really difficult. Like, even a human can't do it. So I think that what we can do is that in open spaces we can do it. In places that we have buildings in one side, it's really risky. So, but of course we are measuring pedestrians. That's something that is not really complex. And if we are in an open space and we don't have pedestrians around us, we can speed up the robot. But most of the occasions, it's really like you have to go at the same speed of a human walking.
Sure. Yeah. Great. Next question is from Jamie.
Yeah. Okay.
So, I'm from Latin America.
Okay.
And robotics is my dream. Can you give me some advice?
Yeah. Like the first advice is to start. So there are a lot of. I actually recommend the first robot that I started. Like the company is called Plum Geek. I started with a robot called Ringo, and it has all the sensors. It has it has a lot of sensors. It's affordable. It costs like $70, and you can run your first Arduino programs, and it's very, very good. So the first one is that if you can afford a cheap robot to start playing around, that's a good one. And also, if you can take like classes online and learn more about that, it's also good. And if you actually want to learn more, join a robotic startup. Yes.
It's a great idea.
Yeah.
So this next question is from Shahuladullah. What kind of AI have you built into your robots? So it sounds like you have a ton of it with the convolutional neural nets. There's probably some deep learning in there, outside of that.
Yeah. So, it's really difficult to define AI, but since, for example, we are using beside the ones that you just mentioned, we are using computer vision to recognize. So there are some times that we need to do sensor fusion. So for the ones that doesn't know what is sensor fusion, is to actually mix all. If you have unreliable data from different sources, you can mix those data and use very fun math and statistics to have a more reliable model. Yes. So one of the things that we are using as a sensor is to recognize patterns in buildings, to navigate. It's still too early, but we have made some very good progress. And it's, for example, with like as human, like before GPS, like human, when you were walking in a sidewalk, you're recognizing which corner just because you recognize that there was a bank in the corner, or there was a restaurant, or there was, I don't know, a poster. So we are using computer vision to recognize those kind of things and teach our robots to like where you are without internet connection or without the need to communicate with a satellite. So those kind of things are things that we are doing, and also like all the computer vision part, like with the neural net and the 3D environment, it's AI. So we have in the model that we are building, we have people, cars, weather condition that we are using like artificial intelligence. Yeah.
Perfect. So this is the last question from our audience. Okay. This is from Shriyam. He wants to know what the state of robotics will be 10 years from now. What do you envision? 10 years is a long time.
Yeah. I think I can talk very confident about my space. So in 10 years, all the last mile deliveries are going to be made by robots. That's going to happen. It's unavoidable, and it's very likely that, and not just in college campuses, in offices, and not just with food, also with importing documents, with small packages, or also with big packages. And what we want to do is to have a Kiwi bot in all those deliveries. And yeah.
Perfect. So that's the goal for 10 years from now. Nice.
Yeah.
So that's it for today's Q&A. If you'd like to learn more about robotics, visit udacity.com/robotics. And don't forget to sign up for our Slack community at robotics.udacity.com. Felipe, thank you very much for your time. It's been a pleasure.
Thanks a lot.
Thanks for coming in.
Yeah.
Until next time.